Can you see my slides? Okay, can see all of you. Okay, so this is worksheet 20. So you see, when you see worksheet 20, you also know that this is our lesson 20 also. Okay, so the first question that we look at, this is on the effects of electricity. Yeah? So if you look at the first question, all right, electrolysis makes use of what kind of effect of the electricity? Okay, so electrolysis, all right, so I have 4 effects here of electricity. Okay, these are the extra notes that I just added in. So formation of bubbles at electrodes during electrolysis is an example of chemical effect of electric current. So of course the answer is very clear here lah, right not? So answer for question 1 is definitely A. But what about the rest of the effects? Okay, so if you are looking at the effects such as, heating or lighting or magnetic, they are all here. Okay, you can take a screenshot if you wish to. Kiran, can turn on the camera, Kiran. Okay, so you take a screenshot. So these are the notes. I think in the open-ended question, it is also being asked about the effects. Okay, you're having dinner, huh? So once you're done, you turn on the camera, okay, Kiran? So late. All right. So meanwhile, you just listen in, all right? So heating effect. So what is actually the heating effect of electric current or electricity? Okay, examples given here, electric iron, electric kettle, okay, electric heater, and the hair dryer. So all of them actually produce some heat that we make use of in our daily life. Okay, when we come to the lighting effect, right, lighting effect of electric current, like the electric bulbs. So we talk about this even in primary school, light bulbs, right? How come the light bulb can light up? It's because of the filament that is actually glowing. When electric current passes through the filament of the light bulb, okay, it gets very hot. Okay, it gets so hot that it starts to glow. When it glows, it emits light. So don't think that these are easy. Yeah? Let's say you are being asked during the exam. You will need to explain, all right, how does the lighting effect come about? How does the heating effect come about? How does the magnetic effect come about? Magnetic effect is also something you've done in primary school. You agree? You created your own electromagnet also. You explored the number of turns that you make, okay, over this iron core. So there's the iron core, that a piece of iron nail probably. You make many turns of wire around it, isn't it? Then you pass it through, or you pass current through this coil of wire, and that piece of iron nail becomes an electromagnet. Still recall all this? Okay, hopefully you do. Ethan, this is not new to you, right, Ethan? Yeah? Okay, good. Now, so later at the end of the class, Ethan, I'll be asking you some questions about why are you here and etc. Can or not? So you let me know what are the things that you want to learn and whether we can help you. Okay. Yeah. So students here, they will do their work and they submit and I track. Okay. So like now, I can actually see a summary of all their responses, but I don't see yours lah because you didn't know that you need to do it in the portal. Okay. Right. So answer is A here. Any question about the rest of the effects? So far, all of you? You say okay, Anaki also okay, Question 1 is actually very straightforward. Right, so question 2, not that difficult also. If you want to find out how much current is flowing through a circuit, there is actually one component you can connect into the circuit. Which of the following should be the one that's connected? So we have already learned last few lessons to measure or even to see how much current is flowing through the circuit. We can put an ammeter here. Okay, so the ammeter connected in series. All right, help us to see, okay, how much current flows through. So how does the ammeter look like? If you have already done electricity in school, you will be able to see how the ammeter looks like. And you need to take note of how ammeter is being connected into the circuit. For example, if I show you now, okay, the ammeter, it looks like this. Okay, Haresh is here. Haresh is late. So if you take a look, this is how the ammeter looks like. Yeah, Ethan, have you seen this before? The rest of them have seen this. I even showed them how this is being connected into a circuit. Okay, if you don't connect it properly, all right, you cannot get the good reading. Yeah, so for example, if let's say, look at this one. Can you see the pin over here? It is pointing to the negative. That means it deflected to the negative side. Why is that so? Because it's not being connected in the correct manner. All right, in the circuit. If you have connected it properly, you should have the reading going towards positive. Just now, that one was pointing at the negative value. Okay, so wrong connection, you don't get a proper reading. Okay, so the main thing you need to do is to flip it over, change the wire over. So if let's say this is the black wire, this is the red wire, you just flip it over and you can get the correct reading. Okay. So go back to the slides. Hi, Haresh. You're here, Haresh. Turn on the camera, Haresh.
Give me a sec.
You having dinner also?
No, I need to fix some stuff.
Oh, I see. Okay. All right. So back to the slides. Okay. This is the symbol, okay, or shall I say that this is how we draw the ammeter in a circuit. Okay. So this is representative of ammeter. This is representative of the voltmeter. Voltmeter looks similar to the ammeter, only that it measures, okay, the voltage or the potential difference across a particular component. This is a fixed resistor, okay, and then this is actually the light bulb, or we call it the lamp. So you need to understand all this. You need to know how to draw all this. Very important. So of course, our answer for question 2 is A. Okay, so Yujie, you get it now? Yeah, so I think you chose the wrong option, perhaps because you didn't revise through while you were doing this worksheet. Correct or not? Never read, right? Never read the notes that I gave you. Never read the textbook. Okay, you're just doing it based on your memory. Hi, Zenith. What happened to Ethan? What Ethan? Got kicked out. Okay, a few more days and you are free. Yeah. Oh, Ethan, you got kicked out just now? Okay, but I see you have 2 accounts. Don't worry about the other one, leave it. Okay, yeah. So Zenith is here, Harish is here. Okay, Kiran, Yujie, okay, all here. Okay, Yujie, you get what I mean, right? Okay, the one that you chose is not the ammeter, it's actually another light bulb. All right, and then I think Zenith also made a mistake here. So Zenith, we already covered the first one. Okay, I go back to question 1 because you all came in slightly later. Okay, so this is question 1. I gave some notes. Why is that so? Because it's important that you know all this. Okay, just take a very quick screenshot of all the various effects of electricity. Ken, it's asked in the open-ended question. So later on, when we address the open-ended question, let me tell you what are the other acceptable answers. All right, so it's not just based on what they have suggested. Okay, done? Okay, good. So we were talking about this. If we want to measure how much current is flowing in the circuit, we use the ammeter, and the ammeter must be connected in series. Okay, so this is the standard requirement. It must only be connected in series in the circuit. So what is the meaning of in series? That means it is part of this path. Okay, part of this path. If it's supposed to be connected, let's say like the voltmeter is supposed to be connected across, I want to find the potential difference of this light bulb. I will connect the voltmeter in parallel across this component. Okay, Ken? All right. Which of the following will have at least one bulb still lighted up, even if bulb X blows? Okay, so if this is the one that has blown, that means there will be an open circuit. Okay, there is no other way electricity can flow. That means these two will not light up. Okay, these two will not light up. Y and Z we also will not light up if A blows. So if you were to look at B, right? So there are actually two paths that current can flow, right? The second path is actually this one. So parallel arrangement of the light bulbs, even if let's say X has blown, okay? Even if X has blown, okay, the electricity will be flowing through the yellow path still. So this will light up. So this must be the answer, isn't it? Okay. Right? Same thing here. If this is the one that has blown, there will be an open circuit. Okay, because this is the main branch it is flowing. All right, so there is no way it can flow to the other branches. Similarly, this is still the main branch. How do you check? Okay, go and use this particular application. Okay, you can actually explore and check. All right, use this application. You can actually find out whether electricity can still flow through or not. All right, any questions so far here?
No.
No? Sure. Okay, so what is the name of this particular electrical component?
So D.
D, variable resistor. What's another name for variable resistor?
Rheostat.
Rheostat. Okay, so that's the one. You will see this word very common from now on. Yeah, variable resistor is also known as the rheostat. Okay, what does the variable resistor do? What does
the current? You can resist the current. You can control the resistance of the current.
Not resistance, but actually just control current. So you actually control current flowing in the circuit. Meaning, if I want to have a lot of the electrical current flowing through so that the bulb lights up brighter, I must make sure I have a low resistance as created. Correct enough? But if I want very, very little current to flow through so that the lamp will be very dim, then I must ensure there's a high resistance there. Okay, Haresh? Yeah, so you got the main point, but if you add in the word resistance, you might affect the answer that you have. Okay, so control the current flowing in the circuit. So high resistance means low current. And when you have low resistance, you will have high current flowing in the circuit. So these are probably the notes that you can take down. All right. And we also saw how to use the rheostat, correct or not, last week. Okay, by adjusting the tap. The moment you adjust the tap, you are forcing the current to flow through, okay, the length of the resistance wire. And that's how we control electric current. Any questions so far? Okay, so Ethan, you might want to find the video on variable resistor. Okay, I showed them a video last week. All right, so find a video on